Find the area enclosed by the curve. Y equals x squared minus 4, the x-axis, and the lines x equals 0, which is the y-axis, and x equals 4. A sketch would definitely help here. Now, let's think about the x-intercepts. The x-intercepts happen when y is 0. So therefore, x squared minus 4 equals 0. That means x squared equals 4, or you could factorize this using DOPS. And then x is plus or minus 2. Now I know that this curve is concave up, or happy as we call it, because the coefficient of x squared is positive. So it's going to look something like this. And the intercepts, they're going to be at -2 and 2. The area we're after is this area and this area. So we're going to have to be careful because this bit's going to end up being negative. So what we can't do is do an integral from 0 to 4 because the bit below the axis will cancel out with the bit above. So what I need to do is do the integral from 0 to 2 of x squared take away 4 dx. So that's going to be x cubed over 3 take away 4x, 0 to 2, using the top limit, that gives me 8 over 3 take away 8, and the bottom limit's just going to give me 0. So that's 8 over 3 take away 24 over 3, which is -16 over 3. Now, if I label these as area 1 and area 2, I can now say that area 1 is 16 over 3 square units. For the bit above the axis, I get the integral from 2 to 4 of x squared minus 4 dx, which is same integral obviously, so x cubed over 3 minus 4x, just different limits, 2 to 4. Putting 4 in there gives me 64 over 3, take away 16, and putting 2 in there we know is going to give us -16 over 3. We worked that out earlier over here. So we've got 64 over 3, take away 48 over 3, plus 16 over 3, which gives me 32 over 3 square units. And that means, of course, that A2 is 32 over 3 square units. Probably should have introduced the square units there rather than on the line above. And so my area is going to be 16 over 3 plus 32 over 3, which is 48 over 3, which is 16 square units. Now there is a trick on the class pad which I can show you for doing that all at once. So what we would do is make use of the modulus function. So what I'm going to do is the integral, and I will go all the way, as I said, because I could do it all at once, from 0 to 4. But instead of putting x squared minus 4 in there, what I'm going to do is put in the modulus of x squared take away 4. And you'll see that that does give me 16. So why does that work? So, well, let's have a look. First of all, let's put in our x squared take away 4. And let's graph that. So that's like the sketch we had before. And now let's put in the modulus of x squared take away 4. So that's going to come up in red. So what you can see, the modulus is the same as the original curve when it's above the x-axis, but anything below the x-axis gets reflected above. So now the whole graph is above and we don't get the problem with negative areas. This has many applications, as you'll see as we go through the rest of the course.